Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy, and today we are continuing our Advanced Algebraic Techniques playlist by looking at how to expand triple brackets. Now, if you're in the UK, this is something that we do with Year 7s from Key Stage 3 and up. In Australia, this is part of Grade 10 and as part of the Australian curriculum. And in order to be able to do expanding of triple brackets, you firstly need to be able to expand single brackets. That was covered as video 7 in our algebraic introduction series. So that's our basic algebra. Jump back there if you're not sure how to expand single brackets. There's a few techniques there that will be assumed knowledge for this video. Also, our previous video, video 6, was all about expanding binomial products. So being able to do double brackets is also important before you do triple brackets. But let's get right into our procedure. Now, what I've done here is I've actually shown you what triple brackets looks like. You've got two terms in each set of brackets. And what I've done is kept the first term the same for all three sets, but that may not necessarily be the case with a question that you get. But usually and typically, the first term may be the same term. ABC represents some sort of number. It could also be an algebra letter that you're being asked to expand out. And typically the cognitive verb that you'll be asked is expand here. Make it bigger, get rid of the brackets. Okay, so first step. You'll just take the first two sets of brackets, x plus a, x plus b, and expand those as per our previous video on expanding double brackets. Same rules apply. You're going to get a new solution there. Now, because there are three letters in these particular ones, three variables, we're going to end up with four terms. Typically, these two could be added together if a and b were numbers. Okay, so then you would end up with three terms in your solution. So what you're going to do is the answer for this, you're going to put into a second new set of brackets, bring down our term that we haven't used yet, and we're going to be basically now expanding double brackets from these two here. Now, because we've got four terms in this second set of brackets, or potentially three terms, you can't use FOIL, firsts, outsides, insides, last, because that's specifically a technique for using double brackets like this situation here. So what you're going to do simply is take this first term and then multiply it individually by everything in these sets of brackets. And then what you're going to do is repeat the process with the second term, C. C multiplied by this, then by this, then by this, then by this. Little thing to remember, the sign in front goes with the term afterwards. So if this is a minus, it goes with this one here. And all of our rules for multiplying negatives are also things you need to keep up in the top of your head. Once you've done that, you're going to have a long answer. You're going to collect any like terms to simplify, and that is basically our procedure. Now, that might sound like a whole lot of mumbo jumbo. It always does until you've got some worked examples. So let's jump into our first worked example. I've tried to keep the numbers really simple for this one. Y plus 1 multiplied by y plus 2 multiplied by y plus 3. So first of all, we're going to follow step 1. We're going to use our FOIL technique, firsts, outsides, insides, lasts, to multiply these two sets of brackets. So I'm going to rewrite the question underneath so that I can work with it. And then I'm going to expand just these two sets of brackets. So the first terms multiplied makes y squared. Outside terms are the ones on the outsides of the brackets. 2 times y makes 2y. Insides, these are our two inside terms. 1 times y makes 1y, and lasts makes 1 times 2, which makes 2. So we've got, this is our answer after we've expanded these first two sets of brackets. Now what I need to do is collect the like terms. I've got two like terms here, 2y and y, makes 3y in the middle. So now I've done the first step, which is to expand the first two sets of brackets. Now what I'm going to do is put this into a fresh set of brackets, and I'm going to multiply it by my final set of brackets, y plus 3. Now you'll notice I've put this in red because what I'm going to do is just do the y multiplying by each of those terms first and pop the answer underneath in the same colour so you can see where that's come from. So y multiplied by y squared makes y to the power of 3. That's our index law 1. We add the indices. Then y multiplied by 3y makes 3y squared. Y multiplied by 2 makes 2y. So you can see here y cubed plus 3y squared plus 2y. Okay, so that's the result of this process here. Our next step now is we're going to multiply the positive 3 by everything in these brackets. So 3 times y squared makes 3y squared. 3 times 3y makes 9y. 3 times 2 makes 6. So I've matched those up there. So you just basically bouncing along and making sure you've covered everything in that second set of brackets. Now our final step is to collect like terms, and there's a few. You can see that y cubed is all by itself. It has no other like terms, but there's a 3y squared and a 3y squared here. Add those together, you'll get 6y squared. You've got a 2y and a 9y here. Add those together, you get 11y. And 6 as a whole number has no other like terms to add to it. So this will be my final answer for this one. You'll notice now we're starting to deal with powers greater than 2 when we multiply 3 sets of things. That's logical because y times y makes y cubed. But obviously these are going to have different rules applying to them. It's not really a quadratic anymore because it's got a power of 3. It makes it a cubic. Okay, worked example 2. I've made this a little more complex now. I've used some more difficult numbers, 5, 6 and 1, and I've given some coefficients to my letters of m. So we're going to end up with some bigger numbers when we multiply this out. So same thing applies. Let's do double brackets first. So let's expand these two. 4m times 3m makes 12m squared. Outsides, 4m times 6 makes 24. Insides, 5 times 3m makes 15, and lasts 5 times 6 makes 30. So this is my result from these two sets of brackets. I can collect the two like terms in the middle. 24m plus 15m will make 39m. So that's my first two sets of brackets expanded. Now I'm going to pop this back into brackets and multiply it by this, starting with 2m first. So 2m will be multiplied by 12m squared. That's going to give me 24m to the power of 3. 2m by 39m gives me 78m squared. So just be really careful with those letters that you're getting the right power on those when you're multiplying. Don't forget to multiply and make new powers. And then 2m times 30 makes 60m. So I've done this first term multiplied by everything in here. The next step will be the number 1 multiplied by everything. Well, basically, if I'm timesing anything by 1, I'm just going to get that result. So that's going to pop onto the end there exactly as it's written, because when you multiply by 1, that's what happens. Okay, now I've got some like terms to collect. 24m cubed will be a standalone. 78 squared plus 12m squared will give me 90m squared. 60m plus 39m will give me 99m, and 30 at the end will be a standalone as well. So once again, 4 terms resulting. Okay, let's make it a little bit harder again with some negatives. Okay, these are the ones that often catch people out with silly mistakes. So same process again. It's really, once you've nailed the process, the rest of it does come a little bit easily. So once again, we're going to expand the two sets of brackets. So first, x times x makes x squared. Outsides, x times negative 2, the sign goes with the number after, makes minus 2x. Insides, positive 7 times x makes 7x. And last, positive 7 multiplied by negative 2 makes negative 14. Then I've got some like terms in the middle to collect. Remember, negative 2 plus 7 will make positive 5x. Okay, so that's my first set of double brackets expanded. Okay, now we're going to be multiplying this one by our third term. So we're going to be doing negatives by negatives, positives by negatives. You're going to have to be really careful with those signs there. Okay, so let's multiply x first by everything in the second set of brackets. So x multiplied by x squared gives me x cubed. X multiplied by 5x will give me 5x squared. X multiplied by negative 14 will give me minus 14x. Fairly straightforward. Now let's do negative 6. Remember, it's negative 6 because the sign in front goes with the number after. So negative 6 times x squared will be negative 6x squared. Negative 6 times positive 5x will be negative 30x, because a negative times a positive makes a negative. And negative 6 times negative 14 will give me positive 84, because a negative times a negative makes a positive. Now I've got some like terms to collect. I'm going to want to be really careful with these because I've got positives and negatives all over the place. So x cubed will be a standalone. 5x squared take away 6x squared will be negative x squared. Negative 14x take away 30 more x will be negative 44x, and then 84 will be a standalone on the end. So really not super difficult once you've nailed the process, just being really careful with those negative numbers. My final example here, I'm going to be using some variables that are letters, just like my very first example at the very beginning when I was outlining the process. I want to show you what happens when we're not using numbers, but we're using pure algebra this time. I could have mixed it up even further. Instead of making these m's, I could have made them 3 different letters as well, but the process will be the same. Okay, so firstly, first sets of brackets. M times m makes m squared. M times y makes my. X times m makes xm. X times y makes xy. And you'll notice on inspection there are no like terms, because remember the definition of a like term is it must be the same letter combination with the same power. So we've got no same letter combinations here at all, so nothing to collect. So now let's multiply that by m take away z, our final term. So I'm going to have m times m squared will be m cubed, m times my will be m squared y, m times mx will be m squared x, and m times xy will be mxy. So once again, there's going to be no like terms there to collect either. They're all very different because they're this one looks like it's the same powers. Well, it is the same powers, but it's a different letter combination. So there's no same letter, same power combination there at all. Okay, so now we're going to multiply the negative z by the rest of everything in that set of brackets at the end. So negative z times m squared will be negative m squared z. You might be thinking, but isn't the z first? Well, typically we write algebra in alphabetical order. So it will be negative zm squared, but we put the m squared first. That's just convention. Negative z times positive my will be negative myz. Negative z times positive mx, negative mxz. Once again, alphabetical order. And negative z multiplied by xy is negative xyz. Now, take a look at this. There's a lot to look at there. You want to inspect that very carefully, but there is nothing there that is a like term. All of those are different letter combinations with powers. So there's nothing you can add. It's just one long answer, and you've got to just leave it at that. Well, did you find this video helpful today? I sure hope you did. And if you want some extra questions to practice on and your teacher hasn't been able to provide that for you, feel free to shoot me an email. You can engage further with the channel by liking and subscribing and hitting that notifications bell so you'll always know when the next videos are available. You could tell somebody. We're on Facebook and Instagram, and you can follow us on social media as well. And if you've got any of those questions or you want some more information or some help with some triple brackets, mcclutchymass@yahoo.com is the place to reach me. Much better to do that than communicating in the comments, because that can get a bit unwieldy, especially when you're starting to talk about some algebra and things going on with negative signs and whatnot. However, if you'd like to tell us in the comments how you found the video and if it was helpful to you, we love to hear from you. Well, thank you so much for your time. I'm Natalie McClutchy. Have a wonderful day.